A problem from Advanced Integration Techniques by Zaid Alyafeai. Okay, so let's solve this problem. So basically, this problem can be written as like this in this form: a to the power minus bx minus 1 plus ax to the power minus 1 by x dx. Now this looks similar to a definition of digamma function. Yeah. So basically we have a definition of digamma function in integral form like this: e to the power minus x minus 1 plus x to the power g by x dx. If you want a derivation of this formula, I will attach it over here. Yeah, yeah, and do check that derivation if you want the derivation. Yeah. Now let us begin with this problem. So basically we don't have 1 plus x as well, and we don't have e to the power minus x as well. Yeah. So that's why let us try to make over here y by substitution y equals to ax. Then we will have dy by a equals to dx. Yeah. So that's why now the limit will go from 0 to infinity itself, and this will be x is y by a. So we have e to the power minus b by, okay, I'm sorry for the, okay, e to the power minus b by a y minus, this is 1 plus y to the power minus 1 by x is y by a, and dx is dy by a, so the a cancel out. Okay, so now we have somewhat to the form that we want, but we still don't have e to the power minus y over here. So for that purpose, what we can do is we can introduce, yeah, we can introduce minus e to the power minus y and then a plus y. Yeah. Okay, so now over here we can use digamma function, yeah, for the second one. And the first one, this one is also a well-known integral, like I will show you about that. E to the power minus b by a y minus e to the power minus y by y. I don't know like why this is happening. Okay, minus y plus the second one is, we know that's the digamma function of this value, uh, that is 1 to the power minus y. Yeah, because when there was g, okay, so basically this is minus g, I'm sorry for that. When there's minus g, at the time we have g over here, I'm sorry for that. So here's minus 1, so we have 1 plus 1 plus y to the power minus 1 by y dy. Yeah. And now about this integral, we also have a standard integral, that integral from 0 to infinity of e to the power minus x minus e to the power minus bx by y. This integral over here is actually minus ln of the first term by second term. If you want a derivation, we can derive this using mass identity. Yeah, you can basically take the from mass identity, you can take Laplace transform for one of the term and Laplace inverse for the other term. Yeah. Okay, so basically all of them are in y, not some of them in x and some of them in y. I'm sorry for that. Yeah. And then we can basically take Laplace transform for the first one and the Laplace inverse for the first one, because this is, sorry, 1 by y, because this is what the mass identity says. So that's why we have integral from 0 to infinity, and this is 1 by s plus a minus 1 by s plus b. Yeah, and the limit remains same, and this is just 1 ds. Now we can have the ln function. So we have ln s plus a by s plus b, and from 0 to infinity. At infinity, this is just ln of 1 minus at 0, this is ln a by b. So you see that this is minus ln a by b. Yeah, and this is a standard integral, and I hope you guys are going to remember this integral for the future as well. Now if we use that, we get minus ln of this thing b by a plus, now this is just diagonal function of if there's minus g, diagonal of g, so this is diagonal of 1, and so this is ln of a by b, and diagram of 1 we know that's negative of Euler-Mascheroni constant. So ln of a by b minus Euler-Mascheroni constant is the answer. And so basically we invoked this definition of diagonal function, and then we used this property, yeah, this integral, yeah, and so we solved this problem, yeah, and this was a pretty elegant solution. Yeah, hope you enjoyed this, and look forward to seeing in the upcoming videos too.